Hey guys, it's Matthew from guidedhacking.com and welcome to a new tutorial on API hooking. By the end of this program, we will be writing a C++ DLL file that upon when injected to Task Manager can successfully hide a process of choice. Before starting this video, I would highly recommend, if you don't have enough C++ experience or low-level Windows API function experience, go ahead and have a look at guidedhacking.com. Feel free to browse the forums, look at some of the other beginners tutorials. I would definitely recommend that before watching this video. So go ahead and create a new project. Once in this project, just choose an empty project, C++, and I'm just going to name this API hook tut. Feel free to name it whatever you like. Once this is loaded, there's a couple things I want to do first. Come here to Project, Properties. Inside this section, you're going to want to switch your target extension to .dll. Feel free to set your project name. I'm going to call this hook2. I'm also going to just quickly change my output directory. Let's set this to, let's put it there. Perfect. And don't forget to change this to a DLL. And make sure you have multi-byte character set already pre-enabled. And go ahead and hit apply. Alright, once you're back onto this screen, go over to Solution Explorer and I assume you already have Visual Studio experience. Go ahead and create just a main file. Perfect. Alright. Once inside here, I'm going to go ahead and predefine a compiler flag, and it's going to be crt secure underscore no warnings. And basically what that'll do is just allow us to use some older standard C functions that I already plan on using throughout this tutorial. Go ahead and include the Windows API, include ps api.h, include for TL help 32. Go ahead and include stdio, and I'm going to include stdlib. I'm not sure if I'm going to actually use it, but we'll just keep it there just in case. And go ahead and include winternal. Just for a quick notification here, we are using winternal to access the function that we're going to be targeting. It is out of this library, not the windows.h library. So first thing that we should definitely do is let's go ahead and write our DLL main. So bool underscore std call DLL main h instance, all that fun stuff. dw reason lp void lp reserved. Perfect. First thing I'm going to do is say return true. Create the case statement, switch statement, and pass it dw reason, obviously to check if the DLL has been injected. Perfect. Before I do anything else, I'm going to go ahead and create our hook function, or declare it. Actually, I'm going to call it, let's call it start hook. Perfect. And in here, don't forget to add that function into there. Perfect. Okay, to start this first, we're going to need to grab some module information of the current program that we are running inside. So let's go ahead and say module info, mod info. Create this structure and set it to 0. You guys might recognize this struct from other video tutorials. H module, grab a module handle, and set that equal to get module handle with a value of 0. Passing 0 as a parameter will get a module on itself. So then we're going to pass get module information, and we're going to pass that the parameters get current process. And we're going to say also h module, that is our module handle. We're going to pass it a reference to our struct, and we are going to give it the size of module info. Perfect, that should be simple enough. Next thing we're going to do is we're going to start parsing through the program's PE header. So we need to declare some initial variables here. So let's go ahead and create an LP byte. Let's call it P address. And we're going to do a typecast for LP byte. We're going to need to grab from our mod info. Oops. What's going on? LP byte mod info dot. That is weird. Oh, I'm an idiot. So make sure to set that equal. Mod info dot LP base of DLL. If you guys don't know, that's basically going to just set a byte pointer to the base of memory of our current module. We are then going to need to start parsing the PE format. So that will start with the DOS header. So we're going to create a pointer to a DOS header structure, and we're going to set that equal to, we're going to need to typecast this, P image DOS header P address. Perfect. The DOS header, if you cannot infer by this, is located at the base memory. So that is very simple for us. And to find the next header that we need, we are going to use some resources from the DOS header to find that. So the next one is called the NT header. We're going to call it PINH. Set this equal to P image underscore NT headers. It should be, I think it should be a single, not multiple. Oh no, it's an S, my bad. Okay, and we're obviously going to typecast, and we're going to say P address plus, and inside the DOS header, we are given an offset, and this offset is ELFA new, and that offset directly points to the NT header. So perfect. And from the NT header, we can easily find the optional header. So let's go ahead, set that equal to image underscore optional header. And we're going to pass this actually a reference to image, NT header and optional header. We're passing a reference because this is not an offset or a pointer, so we're going to need to actually pass a reference to that structure or to that portion of the PE format. Next, let's go ahead and create an image import descriptor. And what this essentially is, this is a section of the data directory that is a part of the optional header that contains information on the functions from public libraries that are currently being used inside this process, including their addresses, their names, etc. So that'll help us to locate the function that we are trying to hook from the Windows API. So let's go ahead and create pimage underscore import underscore descriptor. We'll call it PIID. We're going to set that equal to another typecast here, pimage underscore import descriptor. I'm going to say p address plus pioh data directory. I'm going to say image. I think it should be image directory entry, and this should be import. Yep. Dot virtual address. And what a virtual address is sort of, you can think of it like an offset. So it basically what is stored inside this directory here, under this array with this parameter, is the offset for the actual start of the import directory. So we can find all of our DLL imports. So now we're going to start looping and trying to find the name of the DLL. So we're going to start by just saying, with a loop here, just this PIID and pointing to the characteristics part of that. I'm just basically checking if it's null. And I'm going to say ++. And inside here, we're going to say if not string compare, and it's going to be inside ntdll.dll, and we're going to compare that to a pointer cast of p address plus PIID name. And if that's true, you can just come here and say break. That works perfectly, because each specific import descriptor, there's one assigned per DLL, or included linked library. So that means if we increase to the right one and it compares it, we can just break without doing any more code there. p-image thunk data. The next part we are going to do here is, now we're actually going to loop through this import descriptor trying to find the name of our function. So we're going to create p-image underscore thunk data, and before I continue, what I recommend is going here, copy and paste, because we are going to have to use a second one here. First one, say p address plus PIID, and first one, original first thunk. And let's change the name of this guy. We're going to change this to, let's call it p first thunk test. Perfect. I'm just going to adjust my spacing here, and we're going to set this equal to something similar. And it's going to be a p address plus PIID, and we want just the first thunk this time. Perfect. And then for some reason inside this section there's a specific struct just for the name part of the function sort of descriptor here, so we're going to create that structure but not define it yet. Let's go ahead and now start our loop. We're going to say if not, we're going to say PITD and point to u1.ordinal, and we basically just want to make sure that this is using a functional name, and I mean like a function name instead of a ordinal number. We don't want to scan ordinal numbers. And then next, we also want to say PITD to u1 dot address of data. Make sure there's something there. PITD plus plus. Perfect. All right. First thing we're going to do now is set our import by name section here to a typecast p-image import by name p-address plus PITD u1 dot address of data. Perfect. Once we have that set, now we're able to actually do our string comparison here. So let's go ahead and do a string compare. And the function that we're looking for is called NtQuerySystemInformation. Perfect. We're going to compare that with a char pointer cast of PIIBM dash name. Perfect. And then we can just say break, and we can't forget to also loop this. Perfect. Alright, that looks good. If you guys have any questions about this, just to give some brief information, the reason that we have two of these guys is during the loading process, the way that this was designed is one acts as sort of a template or a placeholder for the other one during the initial loading and grabbing of the public addresses in memory of the dynamically linked libraries. Because if you don't know, a dynamically linked library is essentially where someone sticks a bunch of their library code into RAM, and multiple different processes can say, hey, I want to use that function, instead of having all that memory stored into its own specific program. but for today we're going to be definitely exploiting that. So okay, I'm going to have a couple things for you guys to copy paste down in the comments. We're going to come back up to here, and you're going to paste this, and essentially what this is a custom structure that exactly matches a structure that is used in the normal function, that the original function that we're going to be hooking. And then this is just defining a new type of function pointer, because we're going to grab the address of the original function. So feel free, you can also check this stuff out on the Windows API forums. All the information is there. So we are now going to define a new function pointer, ntQuerySystemInformation. We're going to call it original NtQuerySystem. Oops, I cannot spell information. Make sure I spelled that right. Yeah, we're going to set that equal to a typecast ntQuery_system_information, and we're going to call get proc address. And what we're going to need to do first is we're going to say just get module handle here, and let's go ahead and grab handle of ntdll, and that'll be used to say, actually I'm going to indent here, NtQuerySystemInformation. Perfect. And that will grab our address. Perfect. Okay. So now what we are going to do is let's go ahead and define our hooked function. So what you can do is just go ahead and copy this section here, the parameters, and we're going to define it. It returns an NT status. It is a WinAPI function, and we're going to call this, we'll call it just hooked NtQuerySystemInformation. And inside there we can paste that. Perfect. There we go. Okay, before we continue, I'm going to go down and we are going to quickly finish up this hook function. So now what we're going to do is since we know where the location is, we have it stored in our structure here. Let's go ahead and first make sure that we have the correct permissions on that section of memory. So I'm going to create this to hold the old memory permissions, and we're going to call virtual protect, and then we're going to call, we're going to need to do a typecast lp void of the address of p first thunk test to u1 dot function. Perfect. And then we're going to do size of keyword, because that's just the size of the address. We want page read write, and we'll pass this to GWOld. Perfect. Now we're actually going to write, so let's go ahead and say p first thunk test u1 dot function equals the d word hooked NtQuerySystemInformation. Perfect. Now what I'm going to do is just set the old permissions back by copying paste, but this time saying GWOld and then passing a null. Perfect. And this would be the area now if you want to create like a message box to confirm that a specific part of this process was successful. You can go ahead and create that here. I am not. I'm just going to go ahead and close out the handle for each module. Sure, good white spaces, and then now we're actually going to go up here and write the hooked function. So the first thing I want to do is I actually want to call the original function. So we'll call it nt status. We'll call this status equals, and then we're going to say the original NtQuerySystemInformation. Say or a system basic information class. That should be class. No, it should be system information class actually. System information class. Yeah, that should be right. Yeah, because we're taking it out of up here. So system information is next, and then system information length, and then return length. Perfect. Now that that is set up, we can go ahead and say if system process information equals system information class and status underscore success equals status. Perfect. That's just to go ahead and validate that that function successfully ran. So inside here, we're going to create some of the structures that we define at the top. We're going to say PMY system process information p current. We're going to set that to null. We're going to say now we're going to create another one, and we are going to call this p next, and we're going to set this equal to a typecast PMY process information of system information. Perfect. And then make sure that you do a wide character string compare here, because this function definitely uses a wide character strings. So say p next image name dot buffer. I'm just gonna block out Notepad, so this is where you would enter the name of the exe that you want to actually block out. So I'm just gonna test it with Notepad. We're gonna say for this one, p next image name dot length. Perfect. Now we're gonna go in here and say if not p next to next entry offset, make p current next entry offset. We're going to set that to 0. Sorry, I am just thinking through this a little bit. I think what I should actually do now is I should probably actually, I'm gonna create a main loop here. I'm getting a little bit ahead of myself. We're gonna create a do while loop. We're gonna say p current next entry offset not equal to 0, and then in here, before we actually start, we need to make sure to actually set p current equal to something, so equal to p next, and then we'd set p next to the next available system process information section. We're actually going to do a puchar typecast here of p current plus p current next entry offset. Perfect. Okay, so now this should be set up better. Okay, so now we can come back here. Now we know we got a main loop. We can do else p current next entry offset plus equals, because it's an offset, next, then next entry offset. Perfect. And we can't forget to add a semicolon here and to return status. Perfect. Let's go ahead and try to build this now. So it looks like the build was successful. So what I'm going to go ahead and do is, let's open up a Notepad right here. you guys can see it there. And I'm going to go ahead and open up a file explorer. We're going to navigate, so we wrote this program in 32-bit, so go ahead, go to your C drive or to use as your main drive, to Windows, and to the syswow 64, and we're going to go and find Task Manager. This is the 32-bit version of Task Manager. Feel free, if you want to compile on your own, maybe as an experiment or for practice, a 64-bit version. It's completely possible as well. So you can see Notepad is here. What I'm going to do is just minimize it. You guys can see it down here. Then what I'm going to do is I'm going to go ahead and open up whatever DLL injector of your choice. I'm just going to use one that I wrote. So let's go and open that. And I already should have predefined, yes, my settings. So it's perfect. Target in the Task Manager. We're going to be hiding Notepad. Let's give this a shot. Unable to. Oh, that comes up when you're not running as administrator for your DLL injector. So go ahead and, if you're not already, run your DLL injector as administrator. And let's go ahead and try that again. It was successful, and as you can see, Notepad has successfully been removed from this list. Alright, so now what we're going to do is I'm going to take a little bit of time to just give a little bit more explanation of the code for the people that want more in-depth knowledge behind this. So if I were to sort of pseudocode this, obviously this is our main, and since it's bad practice to write code inside of your main, your DLL main, we have our own function here, start hook, as a void. First thing we want to do is we want to find the base of our module, our memory. And the way to do that is obviously to grab a module handle on itself and fill a mod info struct using get module information. With this information, now we can create and start parsing the PE header until we get to the section of the PE header that contains information about imported functions and libraries. Once we get there, we loop through. We want to find ntdll.dll, because within this library here contains the function that we are trying to hook. And then here we're setting up now, once we find that ntdll.dll, we want to now create the structures that loop through and actually look through for the functions. So once we start that, we can compare it to NtQuerySystemInformation. It's pretty simple. And then here we simply just write our hooked function address into this section, and our hooked function looks a little like this. We call the original one to get its status. We check if it was successful. We declare some system process information structures. We basically have a placeholder, or the current, and then a placeholder for the next one. It's going to check the next one. If there is nothing left in there, and it is also equal to notepad.exe, it found the target program, it's equal to 0. Make sure to set that to 0 because the condition down here says that it needs that 0 to exit. Perfect. And then here, it's going to just skip on to the next one. So effectively what this is doing is just adding its offset if it finds the information instead of sending it over to the user. That makes sense. And that is essentially all. I want to go ahead and thank everyone in the guided hacking community for letting me try out some of my tutorial stuff here. If you guys enjoy, feel free to let me know in the comments, give me some tips. Sort of new to this, but I'd love to hear more from you guys. And I plan on in the future releasing in-depth tutorials on the PE format itself. This is just to give you guys a little bit of a teaser to what is possible with the knowledge of the PE format. Alright guys, I'm going to catch you in the next one. Peace.